Ladies and gentlemen, welcome to Notes 2.4, Adding and Subtracting Numbers in Scientific Notation. The goal of this video is for students to be able to add and subtract numbers that are in scientific notation form. This is the most difficult topic that we will face in this unit, so please make sure you're paying attention very closely through this video, and if you need to watch the video again, please do. So here are the steps for adding and subtracting numbers in scientific notation. The first step is to readjust the numbers so that the exponents are the same. You cannot add or subtract in scientific notation if you have different exponents. That is key. They don't have to be the same if you're multiplying or dividing, but they do have to be the same if you're using addition or subtraction. Let me give you an example. If you have 2x squared times 3x cubed, what you would do is you would multiply the coefficients together. 2 times 3 is 6, and because you're multiplying equal bases, you would add the exponents, so you would get x to the 5th. Now let's take those same terms and let's add them together. So we would have 2x squared plus 3x cubed. In this case, you cannot add these terms together because they have different exponents. If you combine like terms, they have to have the same letter or variable and same exponent. So this is just like scientific notation. You can multiply if the exponents are different. However, you cannot add if the exponents are different. So first step, readjust the numbers so that the exponents are the same. So once you know you have equal exponents, you are able to do step 2, which is add or subtract the coefficients. You know that the coefficients are the numbers that are going to be multiplied by the power of 10. So that would be step 2, add or subtract the coefficient. Your last step, step 3, is to adjust the result to scientific notation. And that just means if your coefficient is too large or too small, you need to make sure that you adjust that coefficient so that it is greater than or equal to 1 but less than 10. So before we start with our examples, let's look at a situation where, and I want you to write this down, where we have 5 times 10 to the 7th plus 8 times 10 to the 7th. If you notice, we have equal exponents, and since we are adding in scientific notation, all we need to do is to add the coefficients. We have 5 plus 8 is 13, and it is times 10 to the 7th. Now notice, we were adding 10 to the 7th, 10 to the 7th. We don't change exponents here as if we were multiplying them. If we were multiplying 10 to the 7th by 10 to the 7th, we would change the exponents. So now you notice we have a coefficient that is too large. That needs to be adjusted, step 3. So 13, it's actually 13.0. Let's count our decimal places so that we can make this a smaller number. We'll count as ones, tens. So we should have 1.3 times 10, which is actually 10 to the 1st, still multiplied by 10 to the 7th. Okay, 1.3 is going to be our new coefficient, and the exponent will be 10 to the 8th. So our answer is 1.3 times 10 to the 8th. So hopefully you understood what we just looked at. If you don't understand that, if you don't understand it really well, what I would like you to do is to rewind the video, watch that section again until you truly understand what I'm talking about with making sure exponents are the same, adding coefficients, and then adjusting that coefficient. Okay, so let's look at example 1, or question 1. We have 2.45 times 10 to the 7th power plus 3.8 times 10 to the 8th power. What I would do first is look at step 1, readjust the numbers so the exponents are the same. We need to do that because here we have 10 to the 7th and 10 to the 8th. We already know how to readjust exponents, so what we would need to do is make a choice. Do we want to change the exponents so they are both 7 or so that they are both 8? You can change either way and you can still come up with the correct answer. So here I'm going to randomly choose to make both exponents 7. So the first scientific notation number, 2.45 times 10 to the 7th, does not need to change. Okay. And so what I would do is copy down the 3.8, and we already know how to do this. The 10 to the 8th we want to write with a 10 to the 7th power. And so we also then will have a 10 to another power that must be combined with a 7 to give us an 8. At this point, that must be a 10 to the first power. So we don't have anything to change here with the first expression. So we're just going to bring down the 2.45 times 10 to the 7th power. Bring down your plus sign. Now we have 3.8 times 10 to the first power. That's what we will focus on now. 10 to the first power is actually 10, so you can think of it as 3.8 times 10, or since there's a positive exponent, you can think of it as this number, 3.8, should get larger by how many place values? Well, one place value because we have 1 0, and so the 3.8 turns into 38. So we have 38 times, bring down the 10 to the 7th power. So please notice what we now have is 10 to the 7th power and 10 to the 7th power. Step 1, readjust the numbers so the exponents are the same. We've done that. Now we are able to go ahead with addition. So step 2 says add or subtract the coefficients, and so we must add, because this is an addition problem, 2.45 plus 38. So make sure when you are adding with decimals, you need to make sure your decimals are lined up. This is actually 38.0. Let's line up the decimal here with the 2.45. Because I have two place values there, let's put zeros as placeholders, and we will add these together. Let's add columns like we know how to do. 0 plus 5 is 5, 0 plus 4 is 4. Let's bring down our decimal point. 8 plus 2 is 10, carry the 1, and there you go, 40.45. So what we have is 40.45 times 10 to the 7th. Be very careful when you add 10 to the 7ths here. You don't change the exponent. You would if you were multiplying. That would be 10 to the 14th. But because we're adding, it's going to stay as 10 to the 7th. Now notice, this is not written in correct scientific notation. Step 3 says adjust the result to scientific notation. Our coefficient is too large. So because the coefficient is too large, we need to move the decimal place over 1. That would give us 4.045, and that is between 1 and 10. Because we moved the decimal place over 1, we can think of this as multiplying by 10 to the first power, and then we have times 10 to the 7th. And at this point, the last thing we need to do is bring down the 4.045, and let's combine the 10s here. They are being multiplied, and so let's add our exponents. So we would have times 10 to the 8th, and there is our answer, 4.045 times 10 to the 8th power. And one last bit of information. If we had at the beginning chose to change the exponents both to 8, we would still get this answer of 4.045 times 10 to the 8th power. We would have had one less step to do, however, because we would not have had to adjust our coefficient to be between 1 and 10. It actually would have already come out to be between 1 and 10. It would have come out right off the bat as 4.045 times 10 to the 8th power. Okay, so on to number 2. In number 2, again, we need to make sure that the exponents are equal. I'm going to decide to make both exponents 8 this time. Not for any reason, that's just what I'm deciding. And so what we have is 2.456 times, now this here, the 10 to the 5th, is what I need to change to 10 to the 8th. So it will be times 10 to a power multiplied by 10 to the 8th. Now remember, when you multiply equal bases, you add the exponents. That means that this exponent has to be added to 8 to give us 5. So it must be negative 3. So we have 2.456 times 10 to the negative 3 times 10 to the 8th. And since this parenthesis here already had the exponent that we wanted, we're just going to bring this down. 6.0034 times 10 to the 8th. So now what we need to do is we need to figure out what this number here is that I'm underlining in scientific notation. So in order to do that, we need to figure out which place is our decimal going to move. So let's move this down to the corner, 2.456. And since I'm multiplying by a negative exponent, it means I'm multiplying by a fraction. This means the number is going to get smaller. And since it's going to get smaller, the decimal will move to the left 3 places because it's times 10 to the negative third. So 1, 2, 3. And we'll see if we can move this down. And we'll fill in our place values with zeros. And so we actually end up with 0.002456. So let's transfer that up here. We'll have 0.002456 times 10 to the 8th power, and that is still added to 6.0034 times 10 to the 8th power as well. So remember, if there's anything that you haven't understood so far, make sure that you rewind the video and watch it again. At this point, we need to make sure, though, that we have exponents that are equal. We have exponents that are equal, 10 to the 8th, 10 to the 8th. So at this time, what we can do is simply add our coefficients. Now my final answer will be multiplied by 10 to the 8th power, but I, at this point, need to figure out what will be my coefficient. And so in order to find the coefficient, we need to add these two numbers here together. So off to the side, I'm going to write 6.0034, and then I will add the 0.002456, but make sure that you line up your decimals. 0, 0, 2, 4, and then 5, 6. Put a 0 in front there. We will need a 0 with the 5 and a 0 with the 6. Now let's add the columns. 0 plus 6 is 6. 0 plus 5 is 5. 4 plus 4 is 8. 3 plus 2 is 5. We have zeros here. We have the decimal point, and we have 6. And so the coefficient for the final answer is 6.005856. And here is our final answer. And one final note about number 2, the coefficient is greater than or equal to 1, but less than 10. So unlike the first example, we don't have to adjust the coefficient because it is between 1 and 10. Okay, let's move on to number 3, and what we have here is 1.4 times 10 to the negative 5th minus 5.67 times 10 to the negative 6th. If you notice, it's an addition or subtraction question, and we have exponents that are not the same. We need to make a decision on which exponent we are going to switch to, and so in this case I'm going to choose negative 5. So I want both exponents to be negative 5. And so what I'm going to do is I'm going to bring down this first number because it has the exponent I want. So I have 1.4 times 10 to the negative 5th. Bring down your subtraction sign. Now I'll bring down the 5.67, and since I need to change the exponent to negative 5, over here I will put times 10 to the negative 5. And remember, I am taking a negative 6 and I'm trying to rewrite it as a 10 to the negative 5, but I would also need 10 to another number. That exponent added to the negative 5 should give me negative 6. And so I believe that that exponent should be negative 1. So continuing with the problem, we still have 1.4 times 10 to the negative 5th. Bring down the subtraction symbol, and now we need to take this scientific notation and find out what that means in standard form. So 5.67, if I take that and I multiply it by a negative exponent, it means I am multiplying it by a fraction. That means 5.67 would get smaller. Since the exponent is negative 1, we're going to move to the left one place. So we have 0.567. That means up here we have 0.567 times 10 to the negative 5th. Now you notice we have equal exponents, negative 5, and what are we going to do with our coefficients at this point? Well, we're going to do whatever the operation in the question says to do. It is a subtraction question, so we are going to subtract the coefficient. So I'm going to have 1.4, and I'm going to subtract 0.567. I need to make sure my decimals line up, so I'll put the decimal here, 5, 6, 7. We do need to add 2 zeros for placeholders. Okay, and now let's subtract 0 minus 7. We need to borrow. Actually, we need to keep borrowing. We're going to go with a 3 here. And now let's carry the 1 over. 10 minus 7 is 3. 10 minus 6 is 4. 3 is too small. Let's borrow from there. Now we have 13. 13 minus 5 is 8. So what we end up with is 0.843. So 0.843. And subtraction means we're going to keep our exponents the same. So unfortunately we're not done because the coefficient is not between 1 and 10. So you notice if the coefficient is too small here, we need to make it so that it's a number between 1 and 10. In order to do that, we need to move the decimal place 1 to the right. That would give us 8.43. And since we moved the decimal place to the right 1, we are actually counting tenths, hundredths, thousandths, and so on. So it's actually like multiplying this by a fraction. So this would actually be 1 place, which is 1/10. Okay, you could think of that 1/10 though as 10 to the negative 1. Okay, and then we still have times 10 to the negative 5. All right. At this point, the only thing we have left to do is to add our exponents. So we have 10 to the negative 6, and so it's 8.43 times 10 to the negative 6, and there is our final answer. Coefficient is between 1 and 10. Okay, at this point we're going to skip number 4. Please wait for the question. Thanks for watching the video, and I will see you next time in class.